Hello and welcome back to another video. In this problem, we're told at the surface of the ocean, the water pressure is the same as the air pressure, 15 pounds per square inch. Below the surface, the water pressure increases by 4.34 pounds per square inch for every 10 feet of descent. So first we're asked to express the water pressure as a function of the depth below the ocean surface. So we're going to let x equal the depth and let y equal the pressure. We're doing this because y is a function of x, pressure is a function of depth. Okay, so let's get some points, x, y, that represent what we're actually seeing in this function. So at the surface of the ocean, so depth x is 0, the water pressure is 15 pounds per square inch, and for every 10 feet of descent, the water pressure increases by 4.34 pounds per square inch. So at 10 feet, it's equal to 15 plus 4.34, right? Or 10, 19.34. So first thing, we want to create the function. It's linear, and we can use the points that we have here and here. The change in y, 19.34, minus 15, over the change in x, 10 minus 0. This is equal to 4.34 over 10. This makes sense. This is the rate of change. And we're told that the water pressure increases 4.34 for every 10 feet of descent. So that's represented in the slope. The slope is 0.434. Now, we have a slope. So we can say for y equals mx plus b, slope-intercept form, y equals 0.434x plus b, the y-intercept. We could find this normally, but we actually already have it given. It's 15, right? It's the value of y when x is 0. So our function, y, the pressure, is equal to 0.434x, the depth, plus 15. We're asked at what depth is the pressure 100 pounds per square inch. So we're asked at what x depth is y equal to 100, so let's just plug 100 for y, is equal to 0.434x plus 15. First, let's not divide, subtract 15 from both sides. This cancels, and we're left with 0.434x is equal to 85. We can divide by 0.434. These cancels, and we're left with x is equal to 85 divided by 0.434. This is roughly 230 if I had to guess. I don't have a calculator on me, but it's somewhere in that range. When you're actually solving this problem, obviously, just find the actual value. But this is the exact depth when the pressure is 100 pounds per square inch, given by this function, which is representing the water pressure at every depth.